Assalamualaikum and a very good day. We are from group 21 and our group consists of 5 members, which are Uzay Aiman Muazzam, Wan Aiman, Zubair, Zikri, and me myself, Khalili Adli. And this video is about the assignment of engineering programming. In the assignment, we have to choose a question and solve it by using MATLAB. In the next part, Zikri will be explained the question that we have choose.
Hi, my name is Mohammed Zikri bin Mahathir with the metric number of 73593. I will be explaining a little bit about our group's engineering problem. We were asked to write a MATLAB program that plots the voltage across the resistor, VR, and the voltage of the source, Vs, as a function of time from 0 to 70 milliseconds. So from our MATLAB program, we would need to compute how many times the diode is turned on and off. A program that solves the problem has two parts. One that calculates the voltage across the resistor VR when the diode is on, and the other when the diode is off. The switch command is used for switching between the two parts. The calculation starts with the diode on, and when the current of the resistor IR minus the current in the capacitor IC is less than or equal to 0. The value of state is changed to off, and the program switches to the commands that calculate the resistor's voltage VR for this state. These calculations continue until the voltage of the source Vs is more than or equal to the resistor's voltage VR, when the program switches back to the equations that are valid when the diode is on. Now I will pass it to the next presenter.
So this is a demo for our program that we have programmed. We broke it down into 3 steps as from the question. That is why I named the M files as step 1, step 2, and step 3.m respectively. Now for the first step, it just shows the variables of the question, which are constant and also one that is changing, which is the C, where I put a command of input value of C, so we can change it in the question later on. And we also put a command of T is starting from 0 until TF, which is 70 milliseconds, with 0.05 millisecond intervals. And then we put down the length of T, which is the number of elements in T, and we named it N. Now for the second step is the calculation. We also broke the calculation into 2 parts, which is where the diode is on and when the diode is off. Now right here, when the diode is on, I wrote down that when the state is on, we put in a loop command for I is equals to 1 until the number of elements in T, because we wanted to calculate how much voltage is being produced in how much time has been passed. So here's the equation from the question itself. Now from the switch state, the case is on, and at this case, the VR or the voltage in the resistor is equals to the voltage of the source. Now if since that it's equal, since the diode is assumed to be ideal, we can find the current in the resistor and also the current in the capacitor. Finding those two, we can add them both and we can find the sum of I. And if, which is a mathematical reasoning, if the sum of I is less than or equals to 0, then the diode is at a state of off. Now when the diode is off, we would like to find the time taken, which is TA, at that off state. Now there is TA equals to TI of where the state is off, and then we end that. The next part is when the case is off. When the diode is off, we would like to find the VR. So since we know when the diode is stopped functioning or is off, we use the equation from the question to find VR, and if the source of the voltage source is bigger than the VR, then that means that the state is on, and then we end the loop command. And the third step is just graph plotting of what we have. Now let me show you how this works. Now if I write down step 1, it asks us to put value of C, which is 45 e negative 6, which is 45 microfarad. Now we have that. We can go for step 2. Now that you can see, it shows when the diode is on and when the diode is off. on off, and when the diode is off, it shows the TA, which is the time when it is off, and on off. And the last part, we can visualize it in the graph, which is step 3 right here. Now you can see here, we will see that when the diode is off, it's going to be where TA is, the first point right here, which is 0.0043 right here. And it goes on and on and on and on until we run out of space. Now the next part I would like to show is the second C value. So I'll just clear this up 1 second, and we go for step 1 again, which is and we put the input value of C, which is 10e-6. And now we have that. We would like to go to step 2 again. It shows when the diode is on and when the diode is off. Now to better visualize this, we put on step 3 and we can have the graph right here. And everything should be the same. It's just when the diode is on and off is different.
Assalamualaikum and hello everyone. My name is Zubair bin Musa. My matrix number is 73890. So I would like to explain the results of our MATLAB problem. So we are comparing two different graphs with the value of capacitor equals to 10 microfarad and the value of 45 microfarad. We can see that the two graphs are differing from each other. You can observe that the graph of capacitor value equals to 45 microfarad is less ripple compared to the graph of capacitor value equals to 10 microfarad. Therefore, we can conclude that a higher value of C will decrease the ripple in a VT diagram, which means that a higher value of C will be more efficient capacitor when we are using a rectifier. We also can say that a higher value of C will ensure that the rectifier will have more stable output voltage compared to a lower value of C. I think that's all from me. Thank you.
Hello, my name is Wanyaman Harith bin Walismadi with matrix number 73873. We'll summarize about our group project. From the problem statement, our group came out with the solution using algorithm first. As from my understanding, it is very similar to a procedure format. After that, we visualized our own solution using flowchart to simplify and to help us understand better of our approach. Then we transform the solution into a pseudocode, which is more on a technical programming language with special keywords on each command. Then we initialize our solution of the problem using MATLAB software to calculate and to find the final answers. I think that is it for the summarization and conclusion. Thank you.